Welcome to the Soilcraft Regen Agronomy Podcast. At Soilcraft, our mission is to innovate and lead in the field of regenerative agronomy, forging a path that empowers farmers to produce food that nourishes and heals both the planet and its inhabitants. Hey, good morning, and welcome to the Soilcraft Regen Radio Podcast, where we talk about this week in regen. So thanks for joining us this week. We're going to talk about, what are we going to call this? The law of unintended consequences, Craig?
I think so.
Craig, we were discussing what are we going to talk about this week? What's going on? And I think it kind of came spurred from some of our last conversation in our previous podcast on, so are you really against this thing anyways? And I think that's kind of part of the reason it would be perceived we're against it, but we're not, right? I mean, some of the reason I think you could argue that some of the reason that so many of us end up here is because of this unintended consequence. We can't look away any longer. We keep seeing these connections. I did this and then that happened. And at a certain point, then the uncomfortable truth becomes, gee whiz, am I part of the problem? Am I causing some of these things? Would you agree that's?
Yeah, for sure. I mean, I think the frustration is you begin down the journey of saying, oh, wait, I need to change, and you begin to do some right things, and then you don't always get the outcomes you want. I mean, I think for me, the big two moments that kind of stood out to me was one day I go out into the soybean field, and I walk out there, and my public enemy number one, amaranth is in my soybean field, and so I go out there, and some guys called me over. They said, "Look at this amaranth," and we go over there, and I mean, it's totally colonized by semi-looper, just thrashing the thing down to a skeleton. And I said, well, that's interesting. These guys, they was being urged to go out and spray my field because these things were present, and they were present on the soybeans to some degree, but they were more present on the amaranth. And so I thought, well, that's interesting. I wonder why that is. And so I started thinking about what would cause that, because I've never seen that before. I'll come back to why that was.
Yeah.
Then the other one would be wheat. You plant a good crop of wheat, you've grown a cover crop, and then you've grown soybeans, and then you feel like you've done the right stuff. You've done certain things related to seed and dressing, and you plant the thing, and it's looking beautiful. It's out of the ground, it's up, it's beginning to tiller, and like clockwork, it seems like You get excited, you fertigate that first good hit of nitrogen, ready to go in, in another week to 10 days with your second set of nitrogen. And what shows up? Fall armyworm, for sure. You start seeing those little window panes, the little peaks to the depths from there. And why is that? Why every year can I almost set a clock and count down and know to go look for armyworms? Probably because I did something. And so I started to think about it. What is it that's causing it? Is it just that date on the calendar, there's always armyworms, or am I, playing a role in this process? And so it started me down the path to think about unintended consequences. What am I doing to myself? And can I stop doing it to myself?
Yeah, and it's a challenge because, we're doing our best, to mitigate those things. So, okay, let's say we do realize, look, I'm drawing a line. I do this and then that. And so it costs me money to put on nitrogen, and I need it, but now it's costing me more money because now it's bringing a pest, and now I need to control the pest. And so, okay, what do we do? Oh, I know the answer. The solution is we put on soil vigor. We put on carbon with nitrogen, and the problem's sorted. And unfortunately, it's not completely sorted. It's mitigated. It's better. And so, okay, now we have less pressure, we're doing better, but we haven't completely fixed it. So, but then we have other strategies. Well, how do we deal with it? Oh, we know they're coming. So, okay, let's reduce this, and then let's apply BT, Bacillus thuringiensis, foliar, so that those fall armyworms are going to be lessening. But then how do we really get to I think the answer ultimately, eventually is, okay, yes, using carbon with nitrogen as we building our soil. So we see OM increasing. And I do believe when we reach, I think the magic threshold is 4%. We reach 4% OM and above, we will maybe reach this kumbaya, the frogs will be singing with the birds. And we can start cycling this so we won't have to put on because we still have to put on more nitrogen to get our crop than we want to. The amount of nitrogen we need, balanced with carbon, is still, I believe, upsetting the balance and creating imbalances which create pest pressure, which we can mitigate in natural ways, but the ultimate end all is there. So that's a pattern. So what other, I know that you mentioned, well, I'll get onto that later about soybeans, but you've also got an instance with soybeans that of unintended consequence.
Yeah. And so I think, just tying off the wheat one, I think that oftentimes our energy and excitement to put down nitrogen and see that wheat plant canopy and, close out the weeds and, get going after a, miserable season of growing soybeans, which most who grow wheat are happy to get rid of the soybeans at the end of the crop. And so you see that, and then you see the impact of nitrogen. Well, we'll I'm sure come back around to, sucking insects, but semi-loopers, at the beginning of the season, it's still warm. Their growth cycles is fast. Your wheat may be the only green thing within, kilometers or miles of that's available, and they show up. And what I believe the correlation is to excess nitrogen early. So if we can lean on calcium, we can lean on other growth stimulants that aren't spiking nitrate levels in your leaves, then you see less pressure. Now, is it 100% solved? No, I can't say it's 100% solved, but I think it's lessened by spreading out those applications and not having excesses at one time. And then you have biological options. You can use the BTs, you can use some of the viral solutions and try to break that cycle so that you don't continue down the train of dependence.
And ironically, you mentioned, adding other strategies. So one of them being using calcium. And instead of just looking at the NPK lever, NPK, sulfur, calcium, silica, so we're adding some levers to this, and calcium being one of those. I mean, calcium is equally as important in early growth as nitrogen. It accounts for the broadening of our leaves and strong cell walls. And ironically, I keep saying that ironically. Why ironically? Because a lot of that early nitrogen that we apply for early growth is often in the form of ammoniacal nitrogen. And what does that do? Ammoniacal nitrogen, remember, has the plus charge as opposed to nitrate, which has the minus. And that plus charge, what it does when it goes in the soil in high rates, especially anhydrous ammonia, is even more so that way. What does it do? It kicks calcium off of the negative charge of the soil and makes it available, and the plant takes it out. So you're telling me when I put on nitrogen, it's just making me absorb calcium? Well, not just, but very much, yeah. There's a balance. Sure, you're using the nitrogen, but it's also kicking off calcium so the plant can use calcium. So what I'm suggesting is if we dial that nitrogen rate back and we're emphasizing, prioritizing calcium more, we can reduce nitrogen by putting on calcium because we don't need nitrogen to release the calcium in our soil as much. So that's also another strategy, as you're mentioning. And then the downstream consequences is not only will it help the soil open up and flocculate, but it'll make stronger cell walls, which are going to be more resilient to those sucking insects as well.
Yeah, because I don't know how it is in all around the world, but certainly here we tend to have high magnesium soils. And so we put the ammonium sulfate on or something of that nature, and you kick off the calcium that is there, and then we wonder why our soils got harder. Well, it's because what's remaining that isn't plant, it hasn't been taken up by the plant, is that magnesium. And so we need to be able to not mine our soils, and you're not going to have good results if you keep mining them out by using chemistry to do that. Maybe jumping over to the soybean one, back to why were the caterpillars in the soybeans. The research that I did, I went back, well, what did I just do? Well, I just had sprayed fuselid in the soybeans. And I was just curious, and I heard somebody talking about, how does it affect the mode of action on the plants and whatnot. And, we always see it. You spray your crop that's doing nice. Soybeans is a classic. You spray them early. They're just growing like gangbusters, and you hit them with the herbicide, the selective herbicide that doesn't affect soybeans. And they sit there for 2 weeks, just creeping along. You're like, are these things still growing? And so I went back and pulled the label out and pulled the bottle out, and on the back of the label it says, used for sugarcane ripening. And so I got curious, well, sugarcane ripening, Why would it make sugarcane ripen? Well, it happens to disrupt lipid production in the plant. And while it wasn't the target species, the non-targeted species were also being affected. And that builds up sugar in your plant because it's not getting processed into something else. And when you're harvesting sugar, that's great. But what it also signals to what we think are our enemies, the undertakers of the world, the insects, is they're just coming to do their job. They're just showing up in the field to clean up dead and dying material that people shouldn't be eating because it's unhealthy, and they're coming up to do their job. And then we see them and we say, well, I just sprayed a herbicide, but now that nasty bug is in my field. Let me go get, and we could name the active, and we go get that and we put that on the plant. And then guess what? That has an impact on the plant health. Oh, wait, that thing also, impacts the cell structure of the plant. No, now it's more susceptible to the sprouting of the fungal spore. Oh, your local drug dealer is going to tell you, hey, no problem. We've got a fungicide for that, a new and improved variety this year, and you're on the hook. You're a full-on junkie at that stage, and so I do appreciate having access to interventions when they're needed, and so I'm not throwing stones, but there's always going to be plenty of people keeping them alive. And so if you want to get off that and you don't want to be dependent on it and you want to use them as a Band-Aid instead of a habit, then I think we have to change what we do. And so we look at it and we say, okay, if I had to use that, what can I do to make sure my plant's healthy? Can I use a foliar? Can I use another action, a tea, something biological or nutritive to mitigate calling in all the undertakers to do their job?
The undertakers, the biological undertakers. It's true. I mean, so along that same line of thinking would be, it's we're solving one problem, and then again the unintended consequences. So let's say we have fungal pressure in a crop, whether it's a mildew or a rust or something. So we're going to go apply a fungicide because the law of unintended consequences, because we put on so much nitrogen early to try and encourage excessive vegetative growth. And we maybe haven't had enough calcium. We have weak, watery cells, thin cell walls, and those fungal spores, or maybe not enough silica, those fungal spores land, and then they put their little spike into there, and so now they're in there. So so what do we got to do? We need to do a fungicide, right? So we go apply a fungicide to kill the fungus that came from our over-application of fertilizer, and then now we sort that problem. So the fungicide kills that, but then, for instance, things that seem pretty innocuous. We think propiconazole, for instance. I mean, just cheap, easy, come on, no
common
harm
on
done.
soybeans, yep.
But propiconazole, tebuconazole, these triazoles, they interfere with sterile biosynthesis, but they also affect the nitrogen metabolism. And so what do you see? You apply a fungicide, okay, it deals with that. But then we see amino acids break down in the plant. And as amino acids break down, they go from amino acids, which are complete proteins, down to peptides, to these small. And so actually we find sucking insects like aphids, they key in. And certain species, actually Tom Dykstra talks about that. They've been doing groundbreaking work on insect herbivory and aphids and mites. And they still haven't been able to release this yet. I'm waiting. I'm digging. Tom, this one's for you. I'm waiting for that information. And I know at some point we're going to realize that, but we're finding now that even literally certain species of aphids will key in on certain amino acids or certain free peptides. And so we see the breakdown of amino acids, and specifically often we see proline showing up. And that's a stress marker. And so, but again, so how do we mitigate that? Well, we also know that when we apply an amino acid, like a hydrolysate, like a soy hydrolysate or something like we make here, that goes into our leaf figure products, that will reduce plant stress and actually can help this. And so, okay, well, sometimes we just got to do it. We got to apply the fungicide. We'll just know that amino acids are going to start breaking down, and it may indicate stress markers, which are going to bring pest pressure. So maybe when we spray that fungicide if we have to, and if for whatever reason we're not using a more biological one, well, why don't we put something like our leaf figure in there that's going to going to reduce the stress in the plant and mitigate some of those stresses again. But not to forget that if we can go back to the law of unintended consequences in the first place, and say, well, why are we applying the fungicide? Well, because we maybe over-applied the nitrogen or something of that sort. Or, and why are we over-applying the nitrogen to our soil in the first place? Why do we need to apply these excesses in the first place? Well, maybe it's because we've forgotten that the synthetic fertilizer is evil, right? Yeah. No, it's not evil. It has advantages and disadvantages. The advantage, it's available now. Yeah. Well, that's terrific. But for something that's available completely now, we shouldn't be stockpiling it. We should be using it now to give us what we need now. If we want to stockpile and put on more nitrogen early, well, then it needs to be complex with nitrogen. Look at manures or stockpiling and cover crops, green manures, etc.
Yeah, and I think that's, for us, I think the biggest change when we did that, we did the cover crop, we did the no-till, we did the adding of carbon in there, and then I bought all the fungicides and left them in the shed, and we began to grow wheat, and we grew wheat, without any fungicides. What dawned on me and was very interesting is when I called in one of our reps for fertilizer and chemistry, and he came out and looked at it and looked around the field, and I said, well, I'm not bad for no fungicides. And he ran back into the field and began looking in the field and came out, and he shook his head and he says, in the 10 years I've been here on the field, this is the cleanest I've ever seen it in relation to septoria. Well, if you're a wheat farmer in Zambia, septoria is enemy number one on wheat in relation to fungal pressures, and that changed. Well, why did that change? Well, I would attribute it to diverse biology being applied regularly among the other systems that were changed to helping to balance out the presence in the leaf structure. We know that moves up from ground splashing up the plants. And if you can balance out those spheres of life, now the things that were your enemies are in balance. Their enemies are there too, and things work better. So I think that's good. I know we're not running out of time quickly, which we do easily, but I think we should also highlight, just look at what you do. I think let's maybe talk about MOP. Maybe it's one of the lowest hanging fruits for talking about unintended consequences and what we see in both the soil and in your plants.
Yeah, MOP is, it's one of those classic, I think, something I learned from my dad and early on in farming is, what I call pay now or pay later. Like, okay, it's more affordable, so I'm saving money. Well, in the case of MOP, you're going to pay, and the interest that comes due on that is massive. You'll pay later.
Not very much later.
And why is that really? And that's because, simply put, the plant needs copious amounts of potassium. There's a reason that we have NPK as the big macros, because the plant needs and uses the majority of those nutrients in conventional agricultural paradigms. So, but it doesn't need much chloride. It needs a very small amount of chloride. And an MOP, and people, I know the first rebuttal will be, well, that's actually a small portion of it. No, it's not a small portion of it. It's nearly 50%. No, if you really want to go down that rabbit hole, you can look at the way they get funny with the way they report potassium and chloride through the forms in MOP. But let me assure you, there is, and even if it was 20 or 30%, which it isn't, there is so much. If there was 2 or 3%, fine. But the plant needs. So what happens? The plant uses the potassium in copious amounts, or it's a salt, so it can leach as well. Either way, the potassium is going to disappear. The chloride is most certainly not. The chloride is going to, but it's a negative charge. It'll go. No, the problem is it grabs onto calcium so readily in the soil. It's going to grab onto calcium, tie up your calcium, and create compaction. And actually, that's almost the best case scenario, because if it doesn't, and it is available, and that's where the plant takes it up. And what happens when plants are in excess in chloride? Well, they're immediately deficient in phosphorus, in selenium, in iodine, in all these supportive elements, in cobalt that are essential to the plant. And it causes some negative side effects, even visibly in the field, hey?
And I think, one of the times where I used it, so we were towards the end of the MOP process, I had stopped buying MOP, but I had it in the shed. And the temptation when you've spent the money already is to use it, right? It's an investment, And so I took my investment out into the field and had it put on to my soybean crop. And within 3 days, the crop had that nice, blue-gray look.
Oh, yeah. Mm.
And guess what happened? About 7 days after that, there were semi-loopers everywhere. And so now I went down to my friendly dealer and got the fix I needed, because I had made a decision to use my investment in MOP. If you've got MOP in your shed and you're on the biological train, sell it to somebody who's not on the biological train. Because think about it. You put chlorine in your pool. You don't put it in your pool to increase biological life in your pool. You put it in your pool to kill everything so that you don't have biology growing, you don't have algae growing. Well, it turns out when you want to be biological, you want algae, you want biology, you want all that stuff, and you don't want to ruin your soil. And your soil, you've already talked about the challenges of knocking off the calcium off of your soils. Now you already are mining calcium. Now you need to look at the whole fact that you're collapsing the structure of your clays, and in some cases irreparably. Yeah. So is that something we really want to do if we're on a path to financial stability, biological sustainability, and just better human health? I don't think so.
And it's an easy switch out. We'll just use potassium sulfate. We need sulfur anyways in most soils, and if you say, oh, but I'm already getting it in my nitrogen, well, that's fine. We can switch things around so that we're getting our sulfur from our potassium and move that around in how we manage our macronutrients. And it's just I promise you'll be so far money ahead if you don't use the potassium chloride. You use SOP instead. And the sulfur is beneficial.
And I know a lot of people, you're already dealing with acidic soils, and you're worried, I'm going to make it further acidic. As your biology takes over, your soils are going to become more neutral. And as they become more neutral, you're going to have much less of an issue. You're going to maybe need the sulfur.
Contributes to OM significantly. Those beneficial organisms that make OM, they need quite a bit of sulfur. And you talk about making protein in wheat. In order to have those complete proteins, you need sulfur. In order to make glutathione in the plant, glutathione is going to be based on sulfur, iodine, selenium, these cofactors.
So before we go for the long 2-hour podcast, I think that gets us started, and I'm sure there'll be a longer form with a lot more unintended consequences. But I think if you have an unintended consequence that you've caused, or you're suspicious, hey, shoot a message over, let's talk about it, and take a look at how we can manage not being our own worst enemy.
Sounds good. Thanks so much for joining us as we expand our paradigms and explore what's possible in the realm of regen agronomy. If you would like to contact us or learn more about what we do, please visit our website at www.soilcraft.com, as well as our YouTube channel. If you have topics you would like us to unpack or stories, please connect with us so that we can share them with others.